Hello my beloved friends, I really hope that you are doing well. Welcome to our today's class. It's our fifth lesson on the third topic of Form 3 work, which is called Newton's laws of motion. As usual, let me commence by giving you the quote of the day, which states that you don't necessarily need to be like anyone in order for you to be someone. We shall discuss that quote at the end of our class today. So today we are looking at the Newton's third law of motion, and it states that if a body P exerts a force on another body Q, Q exerts an equal and opposite force on P. So what this one simply means that if we have a body, for example, a body P exerting a force of 20 Newton on another body Q, then we expect body Q to also exert a force of 20 Newton on body P. So that if you have a body exerting a certain force on another body Q, then we expect the other body Q to also exert an equal but opposite force on the original body P. So the Newton's third law of motion can also be stated as action and reaction are equal and opposite. Yeah. Consider this particular wooden block which is resting on our table here. So if this wooden block is resting or it is stationary, it means that it is not moving. So the weight of this particular wooden block will constitute what we call the action or the action force. So the action force is usually due to the weight of the body. So the resting body, that is the wooden block, the weight or the action force is provided by this particular wooden block. So the weight of this particular wooden block will constitute our action force. So if this wooden block is at rest or it is stationary on this particular table, it means that this particular table will provide an equal but oppositely directed force of 20 Newton. So that force, we call it the reaction force. So if we have a wooden block exerting a weight of 20 Newton on the table, then the table will react by applying or producing an equal but oppositely directed force, which we are calling reaction force. So if the weight is 20 Newton, then the table will provide an equal but oppositely directed reaction force of 20 Newton. So remember, I'm indicating negative 20 to simply show that the force is equal but it is in opposite direction, such that if we choose the downward direction or the weight to act in the positive direction, then the reaction will act in the upward or the negative direction. So action force, which is positive 20 Newton, and reaction, which is negative 20 Newton, they are equal but opposite. So equal because they are both 20 Newton in the magnitude, then opposite because one of the force is acting in the positive direction while the other force is acting in the negative direction. So just a point to note, the action is always provided by the weight of this particular wooden block or the material that is resting on another material. But the reaction force is always provided by the table or the surface on which that particular material or object or wooden block is resting on. Then the reaction always acts in the upper direction. Now, since there is no resultant motion, because the wooden block is at rest, it is not moving, it means that the forces acting on the wooden block are at balance or they do cancel each other. Therefore, the resultant force acting on the wooden block will be 0, and the resultant force will be given by the action force, which is positive 20 Newton, plus the reaction force, which is negative 20 Newton. So positive 20 Newton plus negative 20 Newton, you will obtain a resultant force of 0. Therefore, reaction plus that is the reaction plus that is the action plus the reaction force will give you a net or a resultant force of 0. Hence, the resultant motion of this particular body will be 0. So if the resultant force is 0, it simply means that reaction and the action force, which is the weight, they are equal to each other. Only that reaction is acting in the upper direction while action is acting in the lower direction. But actually, their magnitude are the same, which is mass times gravity or the weight of that particular body. Next, we look at weight of a body in a lift. Let's start by a lift at rest. So if we have a body, for example, this particular person in a lift, but when the lift is at rest or when the lift is not moving, then the machine reads the actual weight of that particular body. So the reading on the machine in this case will be the machine will just read the actual or the true weight of the person, which is weight is equals to mass of the person times the gravity. Then the machine will also read the reaction force of the person, that is the upper, because we know that reaction, that is action and reaction, they are equal but they act in opposite direction. So the machine will read the weight of the person or the reaction of the person, but we know that action and reaction, they are just equal in magnitude, only that they act in opposite direction. So if you're asked to find the weight, that is the reading of the machine when the lift is at rest, you simply find the weight of that particular person by taking the mass of the person multiplied by gravity, which usually we take as that is 10, unless maybe specified. Sometimes we usually use 9.8. Then next we look at lift moving upwards with an acceleration A. So if our lift is moving upward, we have the total upward force acting, which we are denoting by P. Then you also have the weight acting on that particular body, because the weight always acts downwards, because we know that the force of gravity is a force that tends to pull objects towards the center of the earth. Therefore, because the weight is mass times gravity, therefore we expect the weight of a body to always act downwards or towards the surface of the earth. So if you want to find the resultant upward force acting, because here we are talking of a lift moving upwards with an acceleration A. So if the lift is moving upwards, it means that the total upward force must be greater than the weight of that particular object in that particular lift, in this case the weight of this person. So if we are talking of a lift moving upwards, the most important point to note is that the total upward force must be greater than the weight of the person in order for the lift to move upward. Otherwise, if the weight of the person is greater than the that is the force at which that particular lift is moving upward, then we expect that lift to move downward. So if provided the lift is moving upwards, the total upward force must be greater than the weight of the person. Then to find the resultant upward force, we usually take the difference between the weight of the person and the total upward force. But you ask yourself, which force between the total upward force and the weight, which force is greater? And you have said in this case, because the lift is moving upward, the total upward, it means that the total upward force is greater than the weight of the person. Therefore, the resultant upward force shall be given by the difference between the weight and the total upward force. And because the total upward force is greater and we want to find a positive value of the resultant upward force, hence we take the total upward force, then we subtract the weight of the person, because the weight in this case is smaller than the total upward force, and that is why the lift is moving upward. Therefore, the resultant upward force is equals to the total upward force minus the weight of the person. Then if we want to find the reading of the machine, remember the machine will read the total upward force. So we just make P to be the subject of the formula by taking weight to the left hand side and taking F to the right hand side. So if I make P the subject of the formula, we shall have P being equal to, remember the weight, when the weight crosses the equal sign, it becomes a positive. Therefore, we are talking of weight plus the resultant upward force. Therefore, the total upward force is equals to the weight of the person plus the resultant upward force. But we know that the weight of the person is equals to mass of the person times gravity. Therefore, weight is equals to mg. Then the resultant upward force, remember from Newton's second law of motion, we did show that the resultant upward force or the resultant external force is given by the mass of the body times the acceleration. So from Newton's second law of motion, force is equals to ma. Therefore, the total upward force shall be given by mg plus ma. So if I factor out m, we shall have the total equation being the total upward force being equal to mass into bracket G plus A. Of course, where G is the gravity, while A is the acceleration at which that particular lift is moving upwards. So this is the formula that we use for to find the reading of the machine, when the lift is moving upward. So the most important formula to note is that P is equals to M into G plus A. Then we also have another scenario whereby the lift is moving downwards with an acceleration A, So for this particular case, I told you that the most important points to note is that you just consider if the lift is moving downwards, then it means that the weight of this particular person must be greater than the total downward force. So to find the resultant downward force, we usually find the difference between the weight of the person, that is the total weight acting downward, and the total force, or the total downward force in this particular case. So because the lift is moving downwards, hence we talk of the total downward force. Remember that when the lift was moving upward, we were talking of the total upward force. But because the lift is moving downward, in this case, we talk of the total downward force. Then to find the resultant downward force, we simply find the difference between the weight and the total downward force. But you ask yourself, between the total downward force and the weight, which force is greater in this particular case? So what will help you to differentiate between the two is you just look at how the lift is moving. Like for this case, we are told that the lift is moving downwards. So if the lift is moving downwards, that one simply means that the weight, the total weight, is greater than the total downward force. And like for this case, remember here the lift was moving upwards, therefore it means that the total upward force is greater than the weight of the person. That is why the lift moves upward. But for this case, because the lift is moving downwards, this one simply means that the weight is greater than the total downward force. Yeah. So if you want the resultant downward force, we'll simply take the weight, then we subtract the total downward force. So the only thing that is changing is that for this case, you are taking the total upward force minus the weight. Reason being, if the lift is moving upward, the total upward force must be greater than the weight. But for this case, we are taking the weight minus the total downward force. The reason being, if the lift is moving downward, the total weight must be greater than the total downward force, which we are denoting by P prime. Therefore, the resultant downward force will be equal to the difference between the weight and the total downward force. And because the weight is greater in this case, we take weight minus the total downward force so that we get a positive value of the resultant downward force. From this case, we just make P the subject of the formula, that is the total downward force. We just take P towards the left hand side, so P becomes a positive, and we take F towards the right hand side so that F becomes a negative. Therefore, P prime is equals to weight minus F prime, where P prime is just the total downward force, while F prime is the total, that is the resultant downward force. But we know that weight is given by mass of the body times its gravity. Then the force, that is the total downward force, is just the same as the resultant, that is the resultant downward force is the same as the resultant external force, which we derived its formula from the Newton's second law of motion, whereby we said that the resultant downward force or the resultant external force shall be given by MA. Therefore, P is equals to mg minus MA. Then, of course, we factor out mass because it is common. Therefore, the reading of the machine, that is when the lift is moving downward, shall be given by M into G minus A. And of course, in this case, usually A is, we consider when A is smaller than the gravity. So the formula shall be given by, so if you are given a question involving lift moving downward with an acceleration A, you just use the formula, the total downward force is equals to M into G minus A. But if you are given a question involving a lift moving upward with an acceleration A, then you use the formula, the reading of the machine or the total upward force will be the mass into G plus A. Then the last scenario is lift moving up or down with a uniform velocity. So remember, the other term for uniform velocity is constant velocity. And remember, if the velocity is uniform, it means the initial velocity and the final velocity are equal, and therefore the change in velocity, or the difference between the initial and the final velocity, will be 0. So remember, if the velocity is constant or uniform, it means the change in velocity is 0. And if you take 0 divided by t, the answer will always be 0. Therefore, because if the lift is moving up or down with uniform velocity, it means the change in velocity is 0, and hence the acceleration, which is change in velocity over time, will be equal to 0. And if the acceleration is 0, it means the resultant upward or resultant downward force is going to be 0, because remember, F was equals to ma. So if acceleration is 0, it means the whole of this term becomes 0. Therefore, the force acting on a lift moving up or down with uniform velocity shall be equal to P is equals to mg. Yeah, so the force acting will just be equal to the weight of the body that is in that particular lift. So like in this case, the weight of the person will be equal to, that is the reading of the machine. So the reading of the machine P shall be given by mg, because acceleration in this case is 0. Therefore, the formulas would remain P is equals to mg. So the most important thing is to note the formulas, that if you are talking of a lift moving upwards, then P will be m into g plus a. If the lift is moving downward, then we talk of m, that is P, or the reading of the machine, being equal to m into g minus a. If the lift is moving up or down with uniform or constant velocity, then P will be the weight, which is mg. If the lift is at rest, then the machine will read the weight of the person, or the reaction of the person, which is mg. Let's look at an example involving the same. So the example reads that a body of mass 4 kg is attached to the hook of a spring balance hanging from the roof of a lift. What is the reading on the spring balance when the lift is A, ascending at an acceleration of 0.3 meters per second squared? So remember, to ascend means moving upwards. Ascending means moving upwards. Therefore, we use the formula when the lift is moving upward. So the formula was P is equals to m into g plus a. That is for a lift which is moving upwards, or a lift which is ascending. Then we are given the mass of the body, which is 4 kg. Then into the gravity, we are given as 10. Then the acceleration of the body is ascending at an acceleration of 0.3. Therefore, we just substitute the values. So this will give us 4 multiplied by 10.3, which gives us 41.2 Newton. So that will be the spring balance when the lift is ascending at an acceleration of 0.3 meters per second, or when the lift is moving upwards. Part B, we are told to find the spring balance, or the reading of the machine when the lift is descending at an acceleration of 0.2. Remember, descending means it is moving downward. So when the lift is moving downward, we say that the formula that we use is that P is equals to m into g minus a. So you just take g minus a. So the mass of the body is the same, that is 4 kg, into gravity is 10, then acceleration we are given as 0.2. So 10 minus 0.2, you will get 9.8, then 4 multiplied by 9.8, it gives you 39.2 Newton. Then part C, ascending, that is the lift ascending at a constant velocity. Yeah, remember, constant velocity is the same as saying uniform velocity, and therefore we know that if the velocity is uniform, the acceleration will be 0. Therefore, the term having ma will be 0. Therefore, the lift will move, the formula, the lift will be moving at, or the reading of the machine, or the reading of the spring balance will just be the weight of that particular body, which is mg, because the term having ma has disappeared because a is 0. Therefore, P will be mg, which is the mass is 4 kg times gravity is 10, so which gives us 40 Newton. Then question 2 reads that 2 blocks of masses m1, which is 3 kg, and m2 4 kg are in contact on a frictionless table as shown below. So if A force F of 7 Newton acts on M1. Determine part A, the acceleration of the two blocks. So remember, if we consider two blocks, we just combine their masses. So we are given the force F, then we are given the masses. Then they want the acceleration. Of course, the formula that utilizes all those quantities is force is equals to MA, which was a formula that we derived from the Newton's second law of motion. So for the two combined blocks, their total mass will be M1, the mass for the first one, plus the mass of the second one. That is M1 plus M2. So the force is 7 Newton. Then the masses, we have 3 kg and 4 kg. So 3 plus 4, we get 7 kg. Therefore, 7 is equals to 7A. So if I divide both sides by 7, that is 7 is equals 7A. Therefore, A will be equal to 7 divided by 7, which gives us an acceleration of 1 meters per second squared. Then part B, they want us to find the force exerted by M1. So we just consider, we isolate M1, that is the mass for the first mass, which is M1. So they want the acceleration, but remember the same force is acting, therefore force is equals to MA. So our force 1, which is F1, is still what we have found. That is the force. They want us to find the force exerted by MA. Remember, the bodies are moving at a uniform acceleration, or the same acceleration. Therefore, F1 is equals to the mass of the first block times the acceleration of the first block, which is the same as the acceleration, the total acceleration, because the two bodies are moving at a uniform or at a common acceleration. Therefore, F1 is equals M1 A1. Therefore, the mass of the first body, M1, we are given as 3 kg. Therefore, the force will be 3 multiplied by acceleration of 1, which gives us 3 Newton. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that you don't necessarily need to be like anyone in order for you to be someone. So the quote is encouraging us to follow our own inner intuition in order to discover our passion. It is encouraging us to do things that align with our inner self, as opposed to blindly following the majority or following the crowd. And lastly, recall that it's okay to be hated for what you are than to be loved for what you are not. So thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get a notification. If you know anyone who you honestly think could benefit from this content, kindly refer them to Kind Tuition Academy. Thank you very much. Until next time.